This video is going to take you through number 3 from the 7-3 warm-up, and then we're going to finish out the notes for chapter 7, section 3, those repeated factor partial fractions. So for number 3, it just says, find the partial fraction decomposition. We're going to break this down. We want to look at the denominator. We want to see if it's factorable, which in this case it is. Factor it so that it's x minus 4 and x plus 2. There are 2 factors there, so one goes under the a and one goes under the b. We'd multiply the numerators by what's missing from the denominators underneath them. So the a would be times x plus 2 and the b times x minus 4. Now we focus on just the numerators here. So I'd get 3x minus 1 equals a times x plus 2 plus b times x minus 4. And one at a time, we want to cancel out the a and the b. So I'm going to plug in positive 4 and negative 2 to cancel those out. Everywhere there's an x, we're going to plug in that 4. I'd get 12, this is minus 1 or 11 equals a times 6. Here's my 0, so the b is gone. And then I would divide both sides by 6. And I get a is 11 over 6. Repeat that process with x being negative 2. So 3 times negative 2 minus 1 equals a. Negative 2 plus b. Negative 2 minus 4. And this is my 0, so that's gone. Negative 6 minus 1 equals b times negative 6. Negative 7 would equal b times negative 6. And b is 7 over 6, positive because they're both negative. So now when I go to rewrite them back in here, I get 11 over 6 over x minus 4 plus 7 over 6 over x plus 2. And then remember, the fractions can't stay within the fractions. So the denominator of my numerator is going to come down to the bottom, 11 over 6 times x minus 4 plus 7 over 6 times x plus 2. And then we're going to go one step further and take out that 6 in my denominator. So 1/6 on the front, 11 over x minus 4 plus 7 over x plus 2. And there's the solution for the partial fraction decomposition. All right, now the last part of 7-3 with the partial fraction decomposition is ones that have repeated linear factors. So a repeated linear factor is like this down here, this x squared, where you've got something that's repeated, meaning it's going to be squared or to the third power. So this would also happen if I had something like x and then x plus 1 squared. That x plus 1 squared is called a repeated factor. You cannot solve these the way that we've been doing it. If we had factored this to x times x and then x plus 1, you would have ended up with 3 factors, a over x, b over x, and c over x plus 1. And this actually creates 2 problems. One is when we multiply these out to get the least common denominator, it would never be squared. The other thing is that if you were to multiply by what's missing, and then want to plug in one at a time to cancel things out, you'd have to plug in 0 and negative 1, and 0 would cancel 2 of the constants every time. So because of that, we have to approach these a different way. What we do is actually take those factors and we have to build it up to the power that's there. So if you have something that's x squared, I have to do a over x, and then I have to do b over x squared. If it was x to the third, I would do a over x, b over x to the second, and then c over x to the third. You'd have to build it up to that power. And then that last one gets the c and the x plus 1. Now we do the same thing we did before in this initial setup. We focus on what we would be multiplying by here, and what's missing from here to this one, and multiply the numerator by it. So for a, you'd get an x and an x plus 1. For b, you'd get the x plus 1, and for c, you'd get the x squared. Then we focus on just the numerators like we did before. I would get 4x squared plus 2x minus 1 equals ax times x plus 1 plus b x plus 1 plus c x squared. And then again, we said we couldn't cancel these out one at a time because you would have the same number used twice. So this week, we actually are going to expand and group these together. So I'm going to distribute this for both of these. I'm going to rewrite the left side. So 4x squared plus 2x minus 1 equals ax squared plus ax plus bx plus b plus cx squared. Now we're going to group together all the like terms. So everything that has an x squared on it, we're going to group together. Ax squared plus cx squared. Everything that has just an x, we're going to group those together, ax and bx. And then the term that doesn't have anything that's by itself, just that b, would be put last. We're going to set this equal to 4x squared plus 2x minus 1. Now, in order for this to be an equal statement, the x squared terms would have to equal the x squared terms. The x term would have to equal the x terms, and the constant would equal the constant. So we group those together. I would say 4x squared equals ax squared plus cx squared. 2x would equal ax plus bx, and negative 1 equals b. Now on the left-hand side, this first one, we can actually divide everything by x squared. And I end up with 4 equals a plus c. Divide everything here by x. And I end up with 2 equals a plus b. And then negative 1 is b. So if you were to write this out as though it's a system, 4 equals a plus c, 2 equals a plus b, and negative 1 equals b. And here's an actual system of equations. Now what's easy about these is one of them is already solved. So I already know b, which is going to be the numerator on this one. I can take that and plug it back in here to get a. So I'd get 2 equals a minus 1, add the 1. A is 3. And then I can take the a and plug it into the first one. 4 equals 3 plus c, subtract the 3, and c is 1. So now I've got all 3 constants. I'm going to plug them back in the place of a, b, and c here. A was 3, goes over the x. B is negative 1, so I'm going to make this minus 1 over x squared. And c is positive 1. It's going to go over the x plus 1. Now, if we were unsure, we could check by working backwards, and you would get your original question. Okay, we're going to do one more. Again, repeated linear factors. So looking at the bottom, you have something that's squared. So this is going to be a over x and b over x squared because we have to build it up. C gets the x plus 2. Multiply by what's missing. So a is going to get 1x and the x plus 2. B is going to get the x plus 2. And c is going to get the x squared. Rewrite out your numerators. Distribute here and here. Ax squared plus 2ax plus bx plus 2b plus cx squared. Group together all of the x squared terms. So 9x squared equals ax squared plus cx squared. All of the x to the first terms, 3x equals 2ax plus bx. And the constant, negative 1 equals 2b. On the left-hand side, I'm going to divide everything by x squared. And I get 9 equals a plus c. In the middle here, divide everything by x. 3 equals 2a plus b. And negative 1 equals 2b. So here's the first one I can actually solve for. B is now negative 1/2. If I plug that in here, 3 equals 2 times a minus 1/2 You can multiply everything by 2 to get rid of that fraction. Add the 1, 4a equals 7. And a equals 7/4. And then plug that in over here for the a. 9 equals 7/4 plus c. Again, multiply to get rid of the fraction. Subtract the 7. And divide by 4. So here's our A, our B, and our C, and we're going to plug them back in. In place of the A is the 7/4, would go over x. B was the -1/2, it's going to go over x squared. And C, 29/4, is going to go over x plus 2. So bring all the denominators down. 7 over 4x minus 1 over 2x squared plus 29 over 4x plus 2. So this time the common denominator here would be 2, not 4. So you could pull out a half, but you're still going to end up with fractions in the bottom here. So it's not all the way simplified. Either of these answers would have been fine. All right, that finally wraps 7-3. Take the time to submit the notes just for these last, so for the 7-3 warm-up that we started with, and then the 7-3 just examples 10 and 11. And then you can use the remaining time to work on the assignment for the repeated factors. Have a great day, guys.